So that's why the question is how to find a feasible subgradient H belong to this set. This is a set of all possible subgradients. That guarantee is a line. Actually, to differentiate, I think this should be a non-smooth function. For example, so at this point, we have multiple lines that are lower bound. So in this case, the function is non-smooth. So the function is smooth, which means each point you can calculate exactly one type lower bound function. Okay? So again, right? So in order to finish this lower bound function, we need to figure out what is h, right? Okay? And clarify. H belong to Rn. H belong to Rn. So which means we need to find one vector that is lower bound, right? And this is F ST. This represents this is simple. It's defined as a set of all possible subgradients. Okay. So in order to implement this function, we just need to find one subgradient. It's enough. Any one. But we need to somehow calculate what is h, right? So for this reason, maybe maybe you can move this to here. Okay. Oh, I don't know. Maybe I can use this. Right. So which means this is what we want to implement, right? And how to finish this function? We know the function has this form, and the ST is given, right? Because it's previous solution. The solution in previous iteration. And S is our variable. We just need to figure out what is h. If we know what is h, then we know this function. Then we can just maximize this lower bound function. We can finish step 3, right? So now the question here: how can we find a feasible solution? So we have 3 steps. Suppose current solution is denoted as capital Y. Okay? So Y actually, based on this algorithm, Y equal to S0, S1, S2, right? In each iteration, in iteration P, Y is ST, right? So suppose the current solution is Y. Step 1. Basically, we just need to implement 3 steps, so we can calculate h. Step 1. Select a random permutation of 1 to n. So we have a 1 to n, just randomly permuted, random sequence. Actually, I just do not want to move this to the left. Step 1, select random permutation of n numbers, 1 to n, which is sigma. Okay, sigma represents a random permutation. Step 2, we calculate H sigma I equal to F sigma 1 to I minus F sigma 1 to I minus 1. And sigma 1 to I is defined as sigma 1, sigma 2, sigma I. Okay? So basically, sigma 1I basically is the first I elements of one random permutation. Right? And then step 3. We have HS plus FY plus HY. So basically, step 2, we calculate H. It relies on a random permutation sigma. Okay? So, so now let us erase the numerical optimization part. It's okay? So we'll go over one example. I mean, this is how I learn optimization. Usually, if I want to learn something, I want to learn a story. I mean, otherwise, I do not want to memorize. So I want to learn a story from beginning, which is empty. Step, get a final conclusion. So this is how I learn optimization, learn mathematics. So maybe this is a good way for you. I mean, the story is not presented in any lecture, any papers. It's what I figure out myself. Okay? And I will share the papers. The papers related to this optimization algorithms. You will see how complicated the papers are. So now let's go over one example, which is the flight price. Let me the flight price. So basically, suppose function f is defined, right? Suppose your item set is a list of cities. Each item is a city, and you want to select some cities, right? That you want to maximize the price. Just for example, okay? And of course, you know, right? I mean, if I want to maximize price, of course, I just visit all cities, right? Okay? You already know the solution, right? Now, let us just use this simple example to go over and see how exactly, I mean, this algorithm can return all items, and we can set initial S0 to be empty set. Okay, we start from empty again. So initial S0 can be any solution. But usually we just start from empty set, and see how we can start from empty set, gradually enlarge until we include all cities in the set. Okay, and then we do step by step, and you have an idea how to implement the 3 steps. So what is current time now? So let us have a break for 10 minutes. So now it's 6:40. We can start from 6:50.